In this lesson, we're going to discuss velocity as it relates to water hydraulics. As I mentioned before, there's 4 factors to water hydraulics that we're going to discuss here in this course, and those are pressure, flow, velocity, and friction loss. And all of these are intertwined. None of them exist separately from each other. They all affect each other. And so what velocity is the speed that water is moving through your pipe. And that's measured in feet per second, or FPS as we usually abbreviate it, but feet per second. And what we're trying to do is keep our velocity below a certain level, right? In PVC, we want to keep it at 5 feet per second or less. And in copper tubing, it's 7 feet per second or less. And I think if you looking at polyethylene and PEX and so forth, that's also 5 feet per second. So in a later lesson, we're going to discuss how to read a friction loss chart, but we're going to take a look real quickly here at just a clip from one, and you'll see that there is an unshaded area, but there's also a section of the chart that's shaded in gray. That means to stay out of that area. And what's happening is that once your flow gets over the amount that pushes the water through at a velocity over 5 feet per second, if we're talking about PVC here, then it goes into the shaded area. And what happens, because velocity is related to friction loss, and of course flow is related to them all, and so we're trying to control our flow numbers so that we can control our velocity. Because if the water moves too fast, there's the concept of friction loss, which is the amount of turbulence that happens in the pipe. And that turbulence scrubs the pressure down off the amount of pressure that we're designing our system for. So if we're asking too much flow, it means the water has to move too fast. And I'll discuss this a little bit more in detail in a second, but we get too much friction loss. And so once you get over 5 feet per second, the amount of friction loss basically turns parabolic. I mean, it goes exponential to the point to where it becomes diminishing returns. So I discussed before, if you increase the pressure, you can push more flow through the same size pipe, but it comes at the expense of friction loss. The faster the water goes, the more friction it encounters in the pipe. So your friction loss goes up, and then you get to a point to where more pressure equals more flow, and then it'll dip back down because the amount of friction loss just scrubs all that energy away. And if you look and do a calculation in the shaded area, you could see that for a 50%, once you get over that recommended line, for a 50% increase in velocity, you get a 100% increase in friction loss. So that becomes unsustainable past a certain point. And here's something that, designing a system is, the front end calculations that hopefully you're doing a good job with that. And that's one of the reasons I've made these courses. But also if you're going out and doing repairs or doing additions to systems, you got to know that if you take a zone that's been properly designed, let's say it's got 1-inch pipe and it's, moving say 15 gallons per minute, and you add 2 more rotors to that, well, pressure is always trying to meet the demands of flow. Like pressure is like a dog, right? It always wants to please you, right? Pressure is the same thing. Pressure always tries to meet the demand. So if we've got 6 heads, it's doing a good job of meeting that demand. But if we add 2 more heads to it, pressure wants to meet that demand of that extra flow that we're asking from the system by adding 2 more heads to it. Well, the only way that pressure can do that is by increasing the speed of the water moving through the pipe. It's the only way that you can meet that demand, because we're talking about gallons per minute, right? So we're trying to meet that same demand for water in the same amount of time. So the velocity goes up and the pressure loss goes up as well. Now, there's another reason just besides that, besides just losing pressure in the system, is that there's a concept of water hammer. And if you've ever heard water hammer, it's a knocking in the pipes, a dunk, 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 that you hear usually when a valve shuts down. And a lot of times if you hear that in your house, it's because the toilet has shut off. The toilet was running and then it shuts off. Well, it means that you have too much pressure, and when that happens, like as the water is flowing through the pipes and then that valve shuts off, well, that water is going so fast that it's beating against that valve. Well, it's also beating against the rest of the system that water is moving through. So it's banging against the end of your elbows and your T's. So, and this can happen if you don't design your irrigation system well. Not only are you endangering the fittings and everything, the structure of your system that you've put together, but you can beat these fittings right off or snap them. And it usually doesn't break a fitting completely off, but it'll form a crack around it, right? So, and if you make a mistake on the irrigation system, it can affect the house plumbing. And so I hope you've got insurance, right? If they can trace it back to you. But there's things that we can do, right? There are valves that have flow control knobs on the top. And if you're experiencing some water hammer in your irrigation system, and this isn't your fault or whatever, and you can't remove heads to bring that flow amount back down, you can go to the valve and start to crank down the flow control on it. And of course, you run the zone and then you go to the valve and you watch it and you crank that flow control down until the point it starts to affect your performance. And what happens is the spring and the diaphragm will stop that to a certain extent. If it's really bad, it may not stop it. But there's also what's called a water hammer arrestor. And it's just a component that you can get to put on the main line of your irrigation system or on the house plumbing if it's a problem in the house. But let me tell you about what happened in my own house, right? I'm currently in a rental. Like, I don't own this house. I'm between the house I just sold and waiting to buy another one. So I couldn't attend to this quickly myself. I had to call in a plumber who come by. And so it took about, I don't know, it was less than 3 weeks, I think, before they got over here. But the water hammer had gotten really severe. And what had happened is that the pressure regulating valve had failed, right? And it was just wide open. And we measured the pressure on the house, and it was like at 95 psi. So it was too much for the house system. The pipes were too small. So the velocity was really high and it was banging. You could hear it inside the walls, bang, bang, bang. And what happened is, behind the toilet in my downstairs bathroom, it had cracked a fitting, and now water had been dripping inside this wall for nearly 3 weeks and had already started to mold. So that's a problem. And I'm trying to impress upon you the reasons why we control it. Now, if you have a leak out in the ground on your irrigation system, and I mean it leaks, then you're just losing some water, you go and repair it. But your irrigation system can affect your house plumbing in that manner. So we definitely want to keep all of this stuff in line.